Okay, what I'm going to do is show you a couple of the different labs, a couple little demos from Chapter 5. Chapter 5 is called the separation of mixtures, and the whole point is to use what we've already learned about characteristic properties to come up with different methods for separating mixtures. So I'm going to start with section 5.3. Section 5.3 is not a lab, but it is a reading section. However, because of the nature of the section, I can show you a little demo just to kind of help clarify things a little bit. So 5.3 is titled the separation of insoluble solids. Insoluble means that both of the solids will not dissolve in water. They may dissolve in other substances, but they don't dissolve in water. So basically, here's an example, and you can read the section. It's pretty straightforward. The method is called separation by flotation, and using this method, it allows us to separate mixtures of insoluble solids. So here I have a mixture. I don't know if you can see it very well. There we go. There's a little bit of a glare. You see that in there? It's sand and sulfur. There you go. You can see it a little bit like that. It's sand and sulfur mixed together. Both of these solid materials are insoluble, meaning that when I put them in water, they won't dissolve. You can imagine that trying to separate the sulfur from the sand would be somewhat tedious and probably not very feasible just by hand. So what we do instead of trying to separate it by hand is to separate it based on their densities and the fact that neither one of them will dissolve in water. So what I did was this. I took a little bit of our sample of our insoluble solids, our mixture, and I put it into water. What you should be able to see here is that on top, I'm going to tilt it a little bit, trying not to spill it, the sulfur is floating on the top, and the sand has sunk to the bottom. Now, you might be wondering, I don't know if you can tell or not, there is a little bit of sulfur that has sunk to the bottom, and the only reason we see that is because when I mixed it up, some of the sulfur and sand is sticking together, and because the sand is more dense than the sand is actually physically pulling the sulfur down. So the only reason you see sulfur at all on the bottom is because it's mixed with the sand, and I haven't been able to get them to separate. But the sulfur that was separate from the sand is all floating on the top. So the way that this method works is because sulfur is less dense than water, and the sand is more dense than water. So when we put the mixture of sulfur and sand into the water, the sulfur will rise to the top because it's less dense, and the sand will sink to the bottom because it's more dense. So there are two things that have to kind of be in place here. The two solids that are involved have to be insoluble in water, or whatever liquid you're using. This method works with other liquids as well besides water. We always use water because it's the easiest access. So the two solids involved have to be insoluble in whatever liquid you're using, meaning that neither one of them will dissolve. Because if one of them dissolves, this method doesn't work. So that's the first thing. The second thing is of the two solids, one has to be less dense than the liquid, and the other has to be more dense than the liquid, so that when you put them into the liquid, they physically will separate themselves based on their densities. So that is called separation by flotation, and that's section 5.3, which you can read on your own. I'm going to skip ahead a little bit to 5.6. 5.6 is called paper chromatography. Basically, what the purpose of this lab is to take a very small quantity of ink, which if we were to, and you can see on the piece of paper, I just drew one line of black ink. And in terms of the volume of ink that we're using in this experiment, it's very, very tiny. It's a very small quantity of ink. If you were to think about being able to squeeze that amount of ink and measure its volume, it's probably a number that we can't even measure based on the equipment that we have. So that's a very, very, very small quantity of ink. And so this method is going to show us that even when we have a very small quantity of a substance available, we still have ways of being able to separate that mixture. So we have to use this special paper called chromatography paper, and we put a line of black ink. The ink has to be water soluble, which means the ink will dissolve in water. If it's permanent ink, it doesn't work. So we have to use a special kind of ink, otherwise the method doesn't work. So then what we do is we take the piece of paper and we put the end of the paper, not the whole thing, just the very edge of the paper, and we put it into the water. Now, what happens is the reason we have to use this special chromatography paper, you can see it very well, there's such a glare. The reason we have to use the special chromatography paper, I don't know if you can see that at all actually. Well, you'll see it when it's done. The reason we use this paper is because it will actually take the water and pull it up the piece of paper, and it will pull it up through the black ink. So if you think about the piece of paper, oh, you can see a little bit there. If you think about the piece of paper, what's happening is that the very edge of the paper is in water, which is very difficult for you to see right now. Let me see if I can put this behind it. Can you see it this way? No, you can't. Gosh, that glare is terrible. Anyway, the very edge of the paper is in the water, and then the paper is pulling the water up the paper through the black ink. Now, I'm going to put that aside. That needs a few minutes to do what it's going to do so I can show you the outcome. That's the beginning of 5.6. I'm going to go back now to 5.4. 5.4 is called the separation of a mixture of solids. And if you read through it, it's just a half a page on page 103. The difference between 5.4 and 5.3 is that in 5.4, we're going to use a mixture of solids where one of the materials dissolves in water and the other one does not. So, the glare is awful. I keep trying to find a good place in this room to record this without the glare, but I just can't. I don't know if you can see it very well, but it's a mixture of sulfur and salt. The sulfur, as we've already seen, does not dissolve in water, but the salt will dissolve in water. So the difference between this lab and the reading from 5.3 is that rather than both substances being insoluble, one is soluble, one is not. So that's 5.4. So here's what we do with 5.4 in order to separate the two substances. So we have salt and we have sulfur, and then we want to be able to separate them. Now, because one of them dissolves in water, what we do is we take a sample of our mixture and we add it to the water. And then we use the characteristic property of solubility to allow the salt to dissolve while the sulfur does not dissolve. So we mix it up for a little bit and we allow that to take place. We allow whatever is going to dissolve. Mix it for a few minutes. And then what we do is we're going to filter that solution. So basically what's happened, if you look in the test tube, the sulfur is not dissolved and the salt is dissolved. So we're going to take our solution and we're going to pour it through the filter paper. So we put the filter paper in the funnel like this. The filter paper here. And we're going to take our solution. Again, the salt is dissolved in the water and the sulfur is not. And we're going to pour our solution through the filter paper. Now, what's going to happen is, because the sulfur is not dissolved in the water, the sulfur is going to basically get stuck or caught in the filter paper. So the sulfur gets caught on the filter paper while, and what we'll see down here, just a little bit, the rest of the water with the salt dissolved in it goes through the filter paper. So the sulfur gets stuck in the filter paper while the salt water goes through the filter paper. So we're essentially separating it by filtration, allowing the part of the solution that did not dissolve, or the part of the mixture, I should say, it's not a solution, it's a mixture. The part of the mixture that did not dissolve stays in the filter paper, while the salt that does dissolve is pulled through the filter paper with the water. So we call this filtrate. The part of the mixture that filters through the paper is called filtrate. This is the sulfur that stays in there. Let's see, through the filter paper. Yeah. Okay. So then what we do is once this is all drained, let's see where we're at. Oh, we've got a few more minutes with that one. What we do then, once all the liquid has gone through the filter paper, is we take a sample of the filtrate and we pour it into an evaporating dish. Because if you think about it, the filtrate is just salt water. And you guys have seen this before. We've been able to separate the water from the salt before. What you don't realize, what you might, I guess the question you might have in mind is where's the salt, because you can't see it. But you guys know, based on chapter 4 and some other things we've done, that the salt is dissolved into the water. You just can't see it. So we're going to take the salt water, essentially, pour it into the evaporating dish, and then we're going to put the evaporating dish, turn it on, put the evaporating dish onto the hot plate, and allow all the water to evaporate off. So let me show you what it looks like in the end so that we can save a little bit of time. Once all the filtrate has gone through the filter paper and into the test tube, and we pour it in here and allow it to evaporate, we can take the filter paper out and we can let it dry. Once it's dry, this is what it looks like. And you cannot see the sulfur. Goodness gracious. How are we going to do this? There's yellow sulfur on this filter paper. I'm wondering if there's any way at all that you can see this. There's such a glare here. If I do. It's not going to help if I put it on here, I don't think. Let's see. Oh, there we go. Gosh, that's so annoying. Now you can see it, and it's falling off the filter paper a little bit. But that's the sulfur that was stuck in the filter paper. Once you let it dry and you let all the water kind of dry out, you're left with the sulfur. So if you think back to what we started with this mixture, again, which is very hard to see because of the glare. I don't know if you can see it if I put this behind it a little bit. Let me turn it this way, away from the sun. Okay, so you can, actually that works pretty good. You can see it better now. That's the salt and the sulfur mixture. That's what we started with. Then we put some of it in water. We filtered it through the paper. The sulfur got stuck in the filter paper, and when it dries out, we have essentially separated the sulfur. Let's try to do this so you can see it. We've separated the sulfur from the salt. Now, once all the water's evaporated, you can see that we have in our evaporating dish, hopefully this will work. There it is. You can see the salt left over. So there's the salt, and you just saw the sulfur on the filter paper, and we've separated them based on filtration. So here they were originally, mixed together, put some in water, the salt dissolves in the water, we filter that out through the filter paper, sulfur stays in the filter paper while the salt water goes through, then we evaporate the water from the salt water, and we're left with the salt, and then we have our sulfur and our salt totally separate. That is lab 5.4, and again, that's based on the fact that one of the substances does dissolve in water and one of the substances does not dissolve in water. So that's that method. And let's go back to 5.6 now. 5.6. Okay. This is really cool. And I hope you can see it. Yeah, you sure can. Okay. Let's see if that helps if I put that back there. I'll wait from the glare a little bit. Okay. There's the black ink when we separate it out. So if you remember from the beginning, there was a line of black ink across the bottom of the paper. We put the edge of the paper into some water. The paper pulls the water up. Again, you have to have special paper. It doesn't work with any paper. So the paper pulls the water up through the black ink, and as the water moves through the black ink, it separates the black ink into its individual colors. So you can very easily see yellow and red and like a bluish purplish at the top there. And that is another method of being able to separate mixtures. It's called paper chromatography. And that is lab 5.6. I am also going to record tomorrow lab 5.1, which is probably, well, it's definitely the most complex lab in this chapter. And then I will also record for you guys 5.5. 5.5 is not a lab, it's a reading section, but it very easily could be a lab because it describes another process for separating mixtures. And it's one that we sort of have done before with regards to solubility and the effect of temperature on solubility. It kind of goes along with that lab we did from chapter 4. So I'm going to record those two for you as well to take a look at, to kind of supplement the reading and what we're doing in class. If you have any questions, just let me know.